Hello, today I'm going to present a paper called HMD Light Sharing in VR Experience via Head-Mounted Projector for Asymmetric Interaction. So HMD Light is a proof of concept HMD implementation that reveals the VR user's experience in the physical environment. So previously how we've been talking about having a display, instead of having a display, they're just using a projector to do the same in the physical environment. So it makes communication a lot more easier and also improves inter-user interaction between the HMD user and the external user who's not wearing a head-mounted device. So as you can see in this, the external user can see it on the floor. For the limitation of the study, they've used the floor as a point of as a place where they would see the display. So HMD Light allows control of content sharing to the VR user instead of having their perspective or certain restrictions. The VR user can completely choose what they want to show, how much they want to show, and I'll talk more about it. Portable projector is attached to the top of the HMD with a motor. A depth camera is added on the projector to detect and enable external users' touch interaction on the projected display. So as you could see in the previous image, is the person is putting his foot on the display, and the VR headset user can also see that in his virtual environment. Talking about features, there is the most important feature that they focused on is mutual communication. So the idea is that when the external user enters a certain area, so in this paper, it was 2 meters from the VR headset user. That's when the VR user has the ability to share his experience with the external user. And another thing they talked about is the communication reference, which they call the viewport. Basically, this is sort of a channel for them to establish. So once the external user enters the play area, the HMD user can create a viewport. So in this viewport, they have multiple options that they could choose from. So behavior-wise, there are two modes. A mode, which is anchored mode, and T mode, which is tag along mode. So anchored mode, as it sounds, it would be just in one spot. Tag along, as the VR user moves, the external user also sees that view. Spatial setup, so this talks about the position and the size of the screen that the external user sees. Content type, local or non-local view. Local view is basically first-person perspective. So what the VR user is seeing, that's the same thing that the external user would see. And the non-local view, which also has sort of two parts to it. So it's either a view as though it's like a God view, so from the top, and the other one would be third-person perspective, but in a different format than from the top view. They also have the ability to add UI elements to their viewport. So application-wise, I'm keeping track of the time today. So application-wise, they had 4 applications that they decided, and they're wonderful application designs. I'll talk briefly about all of them. So VR scene design, which talks about facilitating discussion. So in this mode, they described a scenario that how a VR user would be brainstorming on how to make a snowman in VR, and then an external user would come in and talk to them about how he could help out. So that's when the VR user would share it in a tag along mode, first person perspective, to see what they could do. And once the external user has given his input, they would have it in anchored mode and third person perspective. So just to have a more stable form of the display. So this one talked about facilitating discussion and having, a point of a very clear channel to talk about. And The next one is VR user direction indicator. It's very simple. It talks about external user experience. So as you can see in the image, the external user can see where the VR headset user is going to go. So it also shows the VR headset user where he's going, because there is a commuted path that they want them to follow, but it also tells the external user that this is where he or she might collide with the VR user. Trample balloons, it's about collaboration. So it talks a lot about the external user having to see a target number. So all the balloons have numbers on them, but only the external user can see the target number. So the VR user would help them find the target number, and then the external user will trample the balloon. The next one and the last one talks about communication. Keep talking and nobody explodes is apparently an adaptation of a VR game. And it talks about how the VR user sees a bomb in their virtual environment, and external user is given a manual to defuse the bomb. So they talk about how, based on the description of the VR user, the external user is going to help them defuse the bomb.